One of the more interesting and perhaps more difficult to use or to understand, not necessarily difficult to use, is the new Iterator Operator. I've highlighted it here in the middle of this particular model. This is a function that lets you embed processing within that iterator that says, okay, I'm going to, outside the iterator, do some processing, and then feed those those streams, those sets of values into an iterator that n times applies whatever functionality is defined within the iterator, produces n results, and might, if those end results are inside the iterator, it'll produce them there. Or if I feed them out, I can feed them out to ongoing processing later in the model. So this is a way of running functionality a certain number of times. It might be do something n times to one set of data, or it might be taking n data sets and run the function on those n data sets one after another, and so on. I should mention what it is not is a while loop. You can't do the counting, you can't trigger the number of iterations within the iterator itself. You have to feed in information that tells it a priori how many times to run. So you can't run this as a keep doing something until a certain certain criteria is met that is being measured within the operator. So just be careful, don't describe this as a sort of looping capability. It is not. It is an iterator. It is part of the flow control functionality within the spatial modeler. What I am going to do is very quickly here start from scratch. I'm going to drag an iterator onto the canvas, or perhaps zoom up a little bit. And this is usually where people stop, instantly as to, well, what the heck do I do now? This operator has no ports. I can't input anything and I can't output anything. What do I do next? I'll go look at the help probably and see if that tells me what to do. That is because really the iterator is a submodel. If any of you are familiar with having used Spatial Modeler in the past, you can create submodels, collapse a large amount of, or a chunk of your model down into a single operator to kind of hide some of the complexity, to tidy it up and pack it away. Well, the iterator in effect is the same thing. It is a submodel. So if I can either select the iterator and click on expand submodel up here on the ribbon, or I can just double click it to descend into my iterator submodel. And again, okay, there is nothing there. Well, obviously it's a submodel and I've got to put something into my submodel. So you then start building whatever functionality you want to run in the iterator. Whatever you're going to do n times, you need to embed in here, and you need to do that trigger of how many times to run, which is usually provided via a list. And the length of that list, how many rows there are effectively in that list, if there's 6 things in the list, the iterator is going to run 6 times. So I'm just, for the sake of argument, or for demonstration purposes, I'm just going to put the add operator on here. This could be, 300 operators connected together, doing whatever functionality I want to do within the iterator. The important things are, within that submodel, the things you feed in and potentially the things you feed out of that set of processing. And I'm going to control that at the boundaries of the iteration submodel using port input and port output operators. And one thing I'll just point out whilst we're talking about port inputs is these are the ways you also now define what shows up in the batch editor, what shows up on the auto-generated run dialogues, and so forth. In prior versions of Imagine, it was kind of hit or miss. You really didn't know what ports might show up to you to be prompted for values. So we decided to clarify that by saying, if you want something to show up as a variable in the batch editor, or you want to show it, prompt the user for those inputs and outputs in the auto-generated run dialogues and preview dialogues, you have to put port inputs, or in very rare occasions port outputs, onto those ports. And because you've put that port input on there, that's going to prompt you in the dialogue. Now here, I'm also going to use that same paradigm for those are going to become the things that are prompted to feed into and out of the iterator submodel. So I want to say, well, port input 1 is my input list. Spell it correctly. And I'm going to, this could be as many ports, not just 2. It could be 3, 4, 5, however many things I need to input to my iterator model. Let's call it other values. Might be multiple, might be a single value. And here is probably one of the very few valid instances where you can use a port output. So I'm going to drag a port output on, put it on there, give it a name. I'm just giving these names because it'll become apparent in a minute why I'm giving it names in this instance. It's because, okay, here's just a very simple kind of example of how you build. Here's all my different functionality. I'm just using the add operator. The important thing with the iterator, though, is these port inputs and port outputs, because when I now collapse this submodel, this iterator submodel, to go back to my main model, click on collapse submodel, now you'll see the iterator has ports on it. It has an input list port, another values port, and an iterator output port. You see now why I named specifically those port inputs and port outputs, so that it will be clear to me when I collapsed that and looked at my iterator, which ports were which values that I now need to feed in. So having done that, I can now go and do things like feed lists that I create onto those ports, add other values, feed the iterator output to the rest of the model, and so on. So that's basically how you start to build an iterator. The important thing to remember is, yeah, it's kind of scary when you drag that iterator across onto your model because it has nothing. There's no ports, you can't bring up a dialogue. The only thing you can do is descend into it, and even when you do that, there's nothing there. You really have to know how to start to build the functionality that you want to iterate through. So having given you the idea of how to start constructing one of those things, let's look at a few examples. And because of kind of the difficulty in grasping this concept, I think I've got 3 examples of using an iterator pre-built for you here that use iterators in various different manners. So this one is kind of the equivalent of, or it's actually part of a larger model that has been available in the past that did some unsupervised segmentation and classification based on zonal values. So here what I want to actually do is run a zonal mean operation. I think that's what it is in here, yep, the zonal mean, on n input bands. And okay, if I only ever have 4-band imagery, I could set this up a different way and not use the iterator. One of the problems is the zonal mean function. If we go and look at the zonal operators down here, zonal mean only works on 1-band data. This is because really it's intended for GIS thematic type operations. You're feeding in zone polygons, and for each of those polygonal areas or raster clumps, you want to look at the statistics from one other layer, the input class raster that's coming into the zonal mean. If I got that the right way around. Yeah, the zones are your effectively polygons, and the class raster gives it away. Class, it's really expecting, it was designed in the past just to take the single band input data. So if you try to feed an N-band image into class raster, zonal mean will choke. It will say you're not allowed to do that. But I want to get the zonal means from 4 bands of multispectral input imagery. Oh no, okay, so I could set a model up that just has 4 branches. It splits out with a band selector, band 1, and does zonal mean on that. There's band 2, zonal mean on that. Band 3, zonal mean on that. And that's great if I only have 4 band imagery. What happens if today I have a 5 band, or a 7 band, or an 8 band, or a 3 band? You know, I want to make my model flexible. So what I want to do is, instead of having n branches running n zonal means, I'm going to use an iterator. And I'm going to use the number of layers operator to find out how many layers the input class raster has. Might have, say, 8 bands. That will then create a table with 8 rows in it, numbered 1 to 8, by using the dynamic table input series operator to build. Start at number 1, increment by 1, with the number of rows coming from num layers. So that'll give me a table, a list that is 8 values long, numbered 1 to 8, and that's what I'm going to iterate on. And obviously I bring my zone raster in. So inside this particular iterator, you can see it brings in my multi-layer raster with a band selection. That band selection comes from the layer number list. So it iterates through that list and looks at, okay, first thing on the list is the number 1. So I'm going to select band 1, run a zonal mean, look at the data through that zonal mean and output it. And then I'm going to iterate again. Next thing in the list is band 2. Okay, I'm going to pick band 2, calculate zonal mean on that band, do a direct lookup, output that layer, and so on through that iteration until it gets to, you know, band 8 or however many bands the input data has, in which case it then finishes the iterations, and all those iterations go into a stack layers operator. So this is outside the iterator. The iterator goes through n bands, outputs those n bands, and stack layers stacks n bands. It doesn't matter how many you feed in, it will stack as many as you have fed through and produce those. So if we just go very quickly go ahead and perhaps preview that, and say my input MS multispectral image is my Iconos multispectral. Going to bring in my, let's see, let's go to, I think it's the land use, land cover. Don't really need the output for the output. So it's now sat there, it's going to iterate through n bands, n times, and you'll see I end up with, interestingly, an n band for, in this case I fed in an Iconos image with 4 bands. So I get a 4-band zonal mean output with band combinations, because that's what I've asked for, that I can still pick, say, band combinations from in that particular data set. Say, perhaps no stretch, or something like standard deviations to apply to that. So that's one example of the iterator. Let's go ahead and turn that off. Clear that out, we won't save the changes. Another example does a thing a little different. This was asked for actually by one of the sales guys a couple of weeks back, that they actually wanted to go through a directory and basically do an operation to every image they find in that directory. And actually it doesn't really matter what the function is. In this case, it was they want to take n-band input imagery and just produce an RGB 3-band output suitable for display in other applications. So they might actually be feeding it out as a 3-band TIFF, for example. So what we wanted to do in the iterator there was basically just do a simple band selection. But again, we need to control how many times is that iterator going to run and what's it going to run on. So we use a new operator, called the multi-file name input operator. This is new for 2016 as well. This does various things, amongst which is that you can tell it to look in a particular input directory on this port and give it a wildcard. So I might just search on star.tiff in a particular directory. I can tell it to search subdirectories. I can actually give it a list of files to use, and they can combine those with a wildcard search and so on. But basically that multi-file name input will build a list of the selected, the found files that meet those criteria. And remember, oh, that's exactly what I need for an iterator, isn't it? I need a list. A list drives the iterator. The list drives how many times it's going to iterate and what it's going to iterate on. So that multi-file name input, very useful. Got to tell it which bands that I want, 3, 2, 1, whatever it may happen to be. Then I also do something a little bit clever that obviously I don't want to give it one output name and have, all the iterations override that same output name. I want to do a little bit clever and name my outputs based on the input root file name, and I also want to put them somewhere that doesn't conflict. So I give it an output directory and convert that to a string using the toString operator, and I also give it an output file name suffix. So if we drop into the submodel, you can see there's my raster inputs, and I do a band selection based on my bands. So if it was 321, it'll grab 321 from a 4-band or an 8-band or whatever it may happen to be, input image, and feed those through the band selection. That's great, that's good. But I also do this get base name. So from the raster input, each time it goes through the iteration, it's going to look at the list, what's first on the list. So that's a file name, a raster input file name that it feeds to raster input. It also feeds that raster file name to get base name, another new operator for 2016. Get base name will just strip everything off so that rather than linear.img, I just get linear. I then use the cat, the concatenate operator, to put my suffix onto the end of linear, so that might be _out.tiff. So I get linear _out.tiff as my string coming through. I then cat the output directory location, actually take that as the first input, and then I'll cat onto the end of that the new file name. So I get basically a string that is a path and an output file name, but it's not actually an output file name yet. It is just a string. So another new operator for 2016 is the convert operator, a very, very useful little operator that converts between data types within the spatial modeler environment. So I can feed this string in to convert, and it will convert to whatever data type that's compatible that I define on the second port. So here I've said I want to convert this string to an imagine.file. So that literally takes my string, looks at it and says, yep, that looks like I can convert it to a file name, convert it to that, and then feed it onto the raster output operator as the output file name in. So I'm getting both my raster stream on this leg, so my band selection, my 3-band raster stream comes in on the raster in port. I give that an output file name on the file name import, and it will go ahead and produce that output data set. Now you'll notice if I collapse it out, this iterator has no output ports. It terminates within the iterator. So this is another way of using an iterator rather than outputting, say, n layers and then outside the iterator layer stacking those. Here I'm literally just going through iterations that produce an output file within the iteration. So file name 1 comes in, and file name 1_out.tiff is written out. Then I bring in file name 2, and I write out file name 2_out.tiff, all within the iterations. Those iterations run and produce an output. I won't bother boring you with running that. It's interesting, though, just to look at that input model dialog. Again, because I've got port inputs here, those are then defined as what shows up on the auto-generated run dialog. So I've got my band selection, and I can just define it as 3,2,1 or 3:1. That will automatically get converted into range lists by the spatial modeler. You don't have to do 3:3, 2:2, 1:1, which is what you saw auto-populated there when I brought the dialog up. That will get done for you. You can see the input directory. It's not a file name. It literally is an input directory that I go and select that is searched using this wildcard, and the wildcard can be as complex as I want it to be, using exclamation marks, asterisks, etc., etc. Whatever it is that you use in wildcard strings for replacements of characters. Output directory and the output suffix, and this suffix incidentally controls the file format. So if I put .tiff on there, the spatial modeler will know to create a TIFF file rather than an IMG file. Or I could put PNG, or I could put JPEG, or JP2, and it will know to create that file type. So we'll close that out and won't save that one. So let's get a little bit more complex now. If everybody's not already overwhelmed with how complex an iterator can become standalone, let's try throwing two iterators into the mix. So this model that was asked for was the equivalent, or getting very close to doing an eliminate function, which you can do in the image interpreter dialogues. So people familiar with clump and sieve, clump, I can go ahead and take a classified image and clump it so that each contiguous grouping of a particular class gets formed into what you could term a polygon in its own right. It becomes a clump and gets labeled with its own unique class number. That one of the things that you then do with that is then sieve. I want to remove all clumps that are smaller than a certain size. And if I bring up a 2D view, I'm going to show you here's the result of a clump and sieve. Here's a classification. Those black holes might not show up unless I change the background value to yellow. But because I sieved out small clumps, I now have holes in my land cover classification. And I want to fill those in. And one of the things you could do in the past was this thing called eliminate, which would do that thing is it, excuse me, it would iteratively run something like a majority filter over the data, applying only at pixel locations of value 0, or the background value, whatever value you tell it to run at, and it will then look at the majority within that moving window area that you define. You usually then exclude zeros from that majority, but that would then, you'd run it once and that would effectively dilate inwards the surrounding classes. And if there was still a hole, it would check for that and run it again. Check to see if there's still a hole, run it again. Check to see if there's a hole, no holes, output the data set. Great, all fine and dandy. Spatial Modeler, unfortunately, still doesn't have looping in it. It does now, though, have the iterators. So what we do in this particular model is kind of fool Spatial Modeler into doing building a process to run a filter n times. And the little trick here, and I still have to define how many times n is. I can't, like I mentioned at the start, this isn't a while loop. I can't do the test internally to the iterator to see if there's still a hole, and if there's still a hole, continue running. I do literally have to say input account, how many times to run this function. But you'll see this is still very useful. We'll come to that in a minute. But what we need to do here is build two iterators. One effectively builds a list of input and output file names, because I don't just want to run the filter n times on the input image, because all that would do would run, say, if I tell it to run 4 times, it would take the input image, run the filter first time. Then it would take the input image and run the filter the second time. Well, you've run the same filter on the same input image, so your results are exactly the same. That's not what you want. You want to run the filter once and produce an output, and take that output and feed it in as input 2. Filter it, produce output 2, which becomes input 3. Filter that, produce an output number 3. Output number 3 becomes input number 4, and so on. So this iterator basically just builds, based on the input file name and the number of iterations that you tell it you want to run, it builds that list of input name and temporary output names. So this model does have to work by creating temporary intermediate files so that it can then run the next iteration of the filter on that temporary file. It will clean them up though at the end, or when you destroy the model, when you clear it out of the spatial model editor, or when the SM process finishes. What I then want to do is actually do the processing. So the second iterator then takes those 2 lists and basically iterates through to use the first list of inputs and populates the output list with values as it iterates through and runs the focal majority function. And it goes through that. Nth item is a new operator, I think, for what are we talking about? 2016. To count through, in this case, the list of output data sets and look at the nth item. So I want to look at the last item and use that actually as my output file. I'm not interested in the other files that got created in that list. I also want to do the little clever bit with clumps that I want to take from my input file name. I want to take that raster input, look at its attributes, especially the color table, and I could add class names as well, and opacity attributes, and all those different things. And I want to reattach those attributes onto my filtered output, and then go ahead and either produce an output image or do a preview. So let's actually do a preview. I'm going to take this particular input, let's clear it out of the view, and I'm going to say, okay, on my model I want to do a preview. I'm going to do a count of 3. Actually, let's do 2 to start with. I'm going to take that sieve image and go ahead and look at it, and that's going to run through and produce my output. Now it actually looks kind of good there until I turn on background, and I think, oops, why'd they not go transparent? Oh, yes, they are transparent. There's one. So you can see it's done a pretty good job. Even with 2 iterations, it's gone through and removed the majority of those holes. But if I zoom in and look around, yep, there's still a few holes here. There's one, there's another. So on my preview, I can come back and look at the input values, increase my count to 3, and oh, as if by magic, my holes disappear. So even though I can't iteratively run this and have it automatically look for when the holes disappear from my data, I can use the nice preview capability of Spatial Modeler to go through, try a value, see if there are still holes there, and if there are, increase the number of iterations, see if they're gone. If they are, now I can actually go ahead and run that model to completion. So now when I go to the full run, it'll use my count of 3, give it an output file name, and it will actually go ahead and run that model to completion at that point. So that's great. I'm going to clear that out.